To all, today we are going to talk about the system name is LiDAR system, and this systems are going to help how to improve the airport security and their enhancement. So let's say, what is LiDAR system? So it's abbreviated says light detection and ranging, and mostly it's using for the laser lights. These lights to scan or sense the object its far distance. Main purpose of the system to identify the distance and obstructions, and its further mapping with integrated system. So mostly we are using this system in the airport technologies. What are the major components we are using for this system is laser emitter, scanners, then receivers, GPS and IMU. So usually these systems using like sender and receiver concept while you are transmitting the data and bounce back the data, and we are receiving some other device. So this is what there's four major components they are using: laser emitter, scanner, receivers, otherwise we can say that is photo detector, and the GPS. So what the function of the laser emitter? So which is a device, it sends the rapid number of pulses towards in the form of light towards the object. So scanners, which is direct the laser beam across the target area. Then third stage, and means third component, it says about the receivers or photo detectors, which can detect the lights that bounce back from the object. Fourth stage is GPS and IMU. So which is track the exact position of the and the orientation of the sensors for the accurate mapping. So these are the four major components using for the system. Then now we are talking about its functioning, how it works. LiDAR emits the burst of laser lights. Okay, it's the high speed of lights. It's emitted from the LiDAR. LiDAR emits LiDAR system to the object. So the light travels to an object and reflect back. Sensor records the time taken return. So the receiver point, it's record the time taken from the object. Then thousands of million points are collected from the object in the 3D callout forms. Now these slides talk about LiDAR object mapping distance. So measurement of the distance. So the distance is equal to speed of the light multiply with the time and divide by 2. So speed of the light, it comes like it says like a laser light. Time taken, the time travel in between from the pulse to object, from object to again the receiver. So this is a round back, like round trip, round trip time taken, so we can say. So the first case is we are going to measure about the distance of the object. We can say distance of the object, or we can say distance of the obstructions of the light, right? So let's consider time taken, it's a 10 nanoseconds, and the speed of the light, it says 299 792 558 millisecond meter per second, and distance is equal to, as I said before, it comes speed of the light and the time taken divided by 2. By doing this formula, we could see we could receive almost 1.5 meter away. Okay, so if you know the time taken of the pulse, we can measure the distance. In other way, we can measure the time by knowing the distance. So could you say the same time trip, we need to find the time taken is equal to 2 multiply with the distance by the speed of the light. So applying the same parameters in the formula, we could get it around 200 nanoseconds for the round trip. So far we seen these objectives and purpose of the LiDAR light and the measurement of the LiDAR distance and the time. Now we are going to talk about applications. LiDAR is mostly using in this airport security by providing precise real-time and 3D data to modeling, to mapping the things. Same thing in the inside the terminals, LiDAR helps the crowd movement and detect the other behaviors and ensure the access restrictions, everything. Same application, intrusion detections, perimeter security. So in the airport perimeters, they will use this device to identify the security of the perimeters. So it can be scan the perimeters on the airport, the real time detecting unauthorized movement into the per perimeter areas. And the 3D surveillance, it's unlike the traditional cameras, unlike the traditional CCTV cameras. LiDAR has the 3D models and it can work in the low visibility areas as well. And surveillance, that's what, like crowd monitoring again and the blind spot elimination. So LiDAR can analyze the flow and the density of the passengers in the terminal, identifying unusual behavior in the terminal inside and passenger boarding areas. And a blind spot elimination, as I said before, unlike the CCTV cameras, LiDAR doesn't relay any of the low lighting object obstructions. It can work full-fledged even the darkness as well. Third stage, we are going to talk about passenger movement and trackings. So here, access control areas and the tailgating detection. There's a both components we are going to talk about here. Track the individual entering and leaving restricted areas. So, so who want to be enter? The access control in generally work for the access for the restricted people, like individual entering who is want to authorized people entering and they exist. This is all exiting. This both cases it can be work. Example, boarding gates and customs. Majorly they are using this kind of technologies. Then we are seeing the runway and airside security. So in the runway, usually the foreign object detection. So RDMS, we can runway monitoring system. So this is integrated with the RDMS system, and it can be identify the debris fall or placed in the runways. Then vehicle tracking also in the air ground, the grounding stops movement and the vehicle movement. Everything is monitored by the LiDAR system. So it can be give the obstacle signals to the workstations and control. They could monitor whether it's allowable object, allowable obstructions or no. That kind of informations they will generate, and it can be mapped to the 3D data as well. So the data they can be measured many method way. Then finally integration with the AI and security systems. Here the smart alerts. When they integrated with the AI, LiDAR can trigger the suspicious activities in the in these sensitive areas. So the smart alerts, it can be user interface through the mobile phones, applications, and the workstations monitor many things. And fusion with the CCTV LiDAR data and can be paired with the traditional video recording system, and it may be provide the alarms as well. So two more slides only. Last one, we are talking about the limitations and its advantages. So as part of the limitation, I can say it's cost effective, and it can be affected by the fog, rain, dust if it is placed in the exposed areas, and large data requires file powerful processing systems. Advantages: works in dark or light environment, and very accurate measurement. Even the distance is no matter for that. It generates detailed 3D spatial data. Okay, so today we learn about something about the LiDAR system. So I'm bringing other topics as soon as possible, which can be supporting to get technical knowledges, and um, I wish to prepare many documented videos like that. Especially it talks about the technical things, which will be helpful to the people. Thank you so much.